Yo, what's up guys? Welcome back to another video. Today we're going to be taking a look at the TaskRipper library once again. My first video was in the Code With Me series about 2 months ago, maybe even more honestly, going over the TaskRipper and creating it from scratch. However, I've long since took a break from doing that. I don't feel like the format right now is that entertaining. Correct me if I'm wrong, but I just think when I'm coding from the beginning and I'm making major refactorings during the same video, it kind of makes it hard to follow. It's not planned as well, you know? So let me know what you guys think. I think the idea is cool, but in practice, it's actually extremely difficult to come up with a plan for the library before you really start implementing some things and run into limitations or things that might take too long, which I'm going to talk about in this video. But aside from all that, guys, if this is your first time tuning in to the TaskRipper, I would love to present it to you guys. Essentially, it's an open source library that helps you execute delegates n times. And what it does is it helps you multi-thread the execution of these delegates on multiple threads and simplify balancing the work for each thread. And that's a huge thing. I see a lot of libraries like the TPL that have the ability to do this. There's also, I think, Parallel for each does this as well. However, the usage for this library is, I think, what's going to attract a lot of people. And the usage is still changing, is subject to change. But what it looks like right now is you create a work contract, which is a contractual, I guess, agreement to do the work. You have a description and the amount of iterations you want to perform. And you have a work executor that you can get by calling default, getting a default instance, or being able to inject it via constructor. And you call the execute async with a particular overload. In this case, it's just an action with no parameters. And here we're writing to the console hello world. And essentially running this line right here will print hello world 100 times. It's that simple. Now here's the thing. What's happening behind the scenes is that there could be any number of threads on your machine, anywhere from 1 to a couple hundred. And the work executor, and essentially the library itself, is figuring out how to balance that work between all the threads that you wish for it to balance on. And it has a really simple interface for describing how to do the balancing. I'm going to go ahead and show you in the code here. If I go ahead and take a look at a work contract has an execution settings. And if I take a look at that, it has a thread range, which defines the minimum and maximum number of threads that are allowed to be used for this environment, and an execution range, which defines a minimum and maximum number of iterations. We have an execution environment here, which defines the number of threads on an executing environment. So the default implementation for execution environment uses the environment class in the system namespace and gets the processor account, which is actually the number of threads. And if we continue, we have a type here, work balancer options. And if we inspect that, we have 5 settings here. And essentially by default, you have optimize, which allows TaskRipper to determine the amount of threads to use and how to balance it based on the number of iterations, the execution range, and the maximum number of threads available. So essentially you would choose this if you don't have much knowledge about the task load and the number of threads that you should use. And then we have more advanced options like min, medium, and high, which basically explicitly tell the system, the TaskRipper, to use a certain number of threads. So minimum would use a minimum number of threads, but still divide the work proportionally. Medium would use the median number of threads available, And essentially you would use this if you want to moderately overload your system with the number of threads available, and high is like overdrive. Use the maximum number of threads available, and essentially this maximizes concurrency of your task. So with all of that being said, some of the items in my backlog is actually improving this. Instead of passing an action and function into these into work execute async method, what I'm going to propose is a work instance. So a work instance has this type of constructor arguments. Essentially, instead of taking in actions or functions, we take in this abstraction, a multicast delegate. If we take a look, a multicast delegate is an abstract class, so there's no instances of it. But you can pass action, any number of action overload delegates, and function as well. And here you pass in the arguments for the executing delegate. And the main difference here is that beforehand, we only have one action, which is the executing action that we're going to execute. But we don't have an action, basically to split the concerns, for controlling the state of the parameter. So for example, this action has a single parameter. It's of type T, but there's no way to control the state of this parameter after every iteration. So the idea is we will have another delegate that's called a mutating state machine. And what it does and what it's responsible for is providing you with the ability to run another function after this execution or before the execution to essentially check the state of the parameters and modify them if necessary. You can think of running the Fibonacci sequence that, the output of the Fibonacci is responsible for producing the next number. So this is a good case to use this overload that accept another delegate for mutating the state of the parameters if you decide to implement it that way. So here's like a beginning implementation. It's nowhere near completion, and it's all in the constructor, which will be moved out. But this is just me testing. Essentially me testing, the return type of void. This is a no return type delegate, and a delegate with no parameters here. And it's a lot more work actually to use this abstraction, because all we have to invoke it is a begin invoke, or in this case we actually only have dynamic invoke because it's actually a multicast delegate and not a delegate. Anyways, another item in our backlog here is being able to support returning all of the results from a function. So a function has a return, and we should be able to get a collection of T results back when we execute this. And so as you can see, the overload here is I work a result with of type T result. And if we inspect that, that contains a dictionary internally of int, which would be like a thread number, and an iteration result, which, if we inspect that, which is the iteration number and the results for that iteration. So here we have all the information about, how many, if we get the count of this property, we know how many threads were used, and every iteration on that thread, we can inspect it for its result. Okay, so now that we talked about that, I might want to introduce something called the iteration context. I don't believe I have a preview of what that would look like, but essentially that would actually directly be in an implementation here. So let's go to implementation and open up this function. If we take a look here, right now I pass null into this work result, and essentially what that null should be is the dictionary of iteration results. And unfortunately, the way I have it set up here is I start the tasks like this using task.start, but task.start does not have any return. So I need to make modifications in essentially how I get the tasks and wrap it. So for example, here, I return an INumerable of t result, a task that returns that. And here I just, I return the number of threads that would run this. So here's a loop that loops through the number of threads. And in each one, we wrap the original task, which is here, and we store the results in a queue. And essentially why we need to wrap it is we need to enforce a cancellation token. And here we could also, enforce, if we have the mutating state machine, which would be an additional function. This is our executing function. But if we had the mutating state machine, we could either, invoke it before or after invoking the executing action. So that's something in the backlog. Sorry if that, is a little convoluted. It is because I don't know exactly what I'm going to do. But anyways, I talked about using the work instance instead of passing in action and function delegates. And we need to make changes to the work balancer. So right now, if we take a look at our work balancer, here's the implementation. We right now, based on the work balancer options, we return a function. And each function describes how to balance the number of threads by returning this dictionary int. So this dictionary is the thread number, which is the key, and the number of iterations it should run. And so here's the math essentially to determine that right now for the optimize function. And basically I might make a implementation like this, that essentially you're able to invoke this. So compute best work balancer options. Basically it will take your action, your delegate, and it'll run it through optimize, none, min, medium, and max, and return the best balancer options. So basically the least number of threads that has the highest or the lowest time of execution. And yeah, so that's something I might want to work on in the future. So other than that, there's probably more backlog I didn't get into this video, but it's already getting long. We're about 13 minutes in. If you guys have any questions or want to contribute in any way, please feel free to leave a comment or, create a pull request or make an issue on GitHub. The project is alive right now, and the more interest in this project, the more interest I have in working on it. And if this is something that you think is important or valuable to you in any way, and you want to see this, see the backlog get done, definitely give a star on GitHub or, let me know in any way again, if you would like to contribute in any way. You could contribute just by commenting about the library. So I appreciate your time. Thank you for watching the video, and hopefully let's get this to 1.1, 1.2 versioning, etc. Thanks for watching. Peace out now.